And we're back. I don't know what I was going to say after that.
But we're back too.
Woo! Hooray! We're going to be looking at one of the top 3, dare I say, top 2 forms of a line today. That's right. It's slope-intercept time. Now, we're not all in agreement as to where it exactly ranks, but we can all agree that it's top 2. Does anyone rank it higher than that here?
Yep, I do.
Yeah.
Top 1 for me.
Yeah, top 1 for me too.
It's all right. I'll be the minority. I'm used to it. Anyways, slope-intercept form is this thingy here. Y equals mx plus b. You'll probably hear y equals mx plus b a whole bunch of times. It's a very excellent form of a line. Kind of gives us a starting point as a natural contextual starting point, which we might see one day in our lives. I don't know. See where the road takes us. But what this stuff means, x and y still mean the points x, y. M is still your slope. And this thing that's labeled as b is actually the value of your y-intercept. That y-intercept is essentially a starting point. It's a point that we can graph on the line right away and then possibly use the slope to get some other points. It's pretty wicked. I will take you through one whole graphing example. So the slope here, if this thing is the m and this thing is the b, the slope is 2. The intercept is at 4. If you want to state where those coordinates are, you could say it's the point 0, 4, based on how we know how intercepts work. Now in graphing, those things you have to do still apply. You still have to label your axes. You still have to label your scale. And from there, you can start plotting all of the points. Again, y-intercept is 4. I would start with that. Then since the slope is 2, we proceed from here just as we do with slope point form. We use the slope to get to a next point, up 2 over 1, up 2 over 1, and then continue the pattern same direction. This is old hat, as some might say, for us now. And I get my trusty ruler out. Brings me so much joy and happiness. And of course, I finish off with arrows, because this thing goes on forever, ever. Forever, ever? Forever, ever. I'm throwing up the pen. Catch it.
Ah! Got him. All right. Our next example here, same idea. We're going to pick a color. And so we're going to distinguish our slope. Our slope is represented by that m, and our y is equal to mx plus b formula. So we have our slope is -3. Our y-intercept here is our +2. And if we'd like, we could indicate that as a coordinate point. We know all y-intercepts occur when x is equal to 0, so we have 0, 2. We go ahead and we label our axes. Our vertical axis is our y-axis. Our horizontal axis is our x-axis. And we got some scale up in here. So we've got that be a 1, that be a 1, and ooh, mama, we're cooking. All right, we are going to start by plotting our y-intercept. So that occurs hither. And we are going to use our slope of -3. So we are going down 3 and over 1. Boop, 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 boop. Here we go. And we're going to continue on in the same fashion. Oh yeah, so nice. And then we backtrack. Oh yeah, also so nice. I'm going to find me some ruler. And I'm going to connect all damn dots though. And I'm going to make arrows at the end to indicate that it goes on forever. And then I'm going to pass this over to your trusty teacher, Mrs. Friesen.
Ooh, there's some alliteration. Whoa. Okay, so let's pick a fun color. There we go. Sounds good. We're going to identify our slope, which we always find in front of x, and y equals mx plus b. And that gives us a slope of 1/2. Let's write that a little more nicely. There we go. And then our y-intercept follows the x value. That's our b value. Remember that when we look at the formula, y equals mx plus b, we have a plus sign here, so that if our b value was negative, it would end up looking like a minus, like here. And so that means that our b value is the whole thing, including the sign. Okay, so remember to take the sign with it when you take the y-intercept out of the y equals mx plus b slope-intercept form of a line. You can also rewrite that, like we've been talking about, as a coordinate point, if that's helpful. Okay, let's do some axis labeling. X, Y. That's not going to show up on the graph, though. I need to pick another one for the scale. Okay, 1 and 1. Okay, then we are going to use those trusty plotting skills that we have been working on, starting with my y-intercept of 0, -1, read off of the equation. And we're going to use our slope, which is 1 over 2. So remember, rise 1, run 2 to get to here. And then follow that pattern until we get to the edge of the graph, and then reverse all the way back to the other edge of the graph. Okay, and then the ruler is going to help us make a great straight line, and we will just have to put the arrows at the end afterwards to complete our work. Voila!
Whoa.
I can do this too. Oh, wow. Sorry, I wasn't watching when you put that yellow on. That looks nice.
Oh, thank you.
Right? Look at that pop.
Yeah, yeah.
What colors have we used? Interesting, interesting, interesting. Boop. This thing has a slope. This thing has a y-intercept. I have axes. I have scales. Like a fish. Y-intercept is 3. Slope is -2/3. I can totally figure out other points from this. And playing connect the dots. Again, make sure you actually are using a ruler, because if you get this like wavy line nonsense, well, it's nonsense. So how are we supposed to interpret it? But seriously, use a ruler. Wow, I think that looks right. Looks right.
It's beautiful. It's beautiful.
Thank you. I was just going to shoot for height, but I'll take beautiful. Yeah. Appreciate.
All right. So we've established that at this point we are able to graph a line given our equation in y is equal to mx plus b form. But the real test is, can we backtrack? If we are given the graph of the line, could we now go backwards? And the answer is going to be yes, because we're capable of anything, because we're a strong, smart, and just absolutely wonderful group of people. All right, so keep in mind here that we have our slope-intercept form that we're using. So that is our equation. We need to find our slope. We need to find our slope, and we need to find our y-intercept in order to complete the equation of the line. So taking a peek at our example here, the first thing I like to do is I like to find my y-intercept first. The order really doesn't matter in which you find it, but you do you. And here we have it. So that is our y-intercept, and that occurs when y is equal to 1. Yeah? And so our b value is going to be equal to 1 because b represents the y-intercept. Next, we need to find the slope. So to find the slope, the easiest way I find is to look for 2 points on our graph that work out super nicely. So one of them could be our y-intercept. The next one that I could see here lines up exactly at one of the coordinate points on our graph. And we can go ahead and calculate our slope. Remember that slope is our rise over our run. So we're going to see how much we've risen and how much we ran. So taking a look, I'm going to choose a different color. We went down 1. So our rise is going to be -1. And we ran over 1, 2, 3. So we get a slope of negative 1/3. Did you feel?
Which I definitely feel.
Wicked. So our final equation is actually just going to be putting those two values together. Instead of m, I'm going to put negative 1/3. Instead of b, I'm going to put 1. And I'm going to call it a day. So I've got y is equal to negative 1/3 x plus 1. Woo!
All right, last example.
Woo-woo!
Okay, so we are going to do exactly the same thing as what we just looked at. So we're going to use our trusty form of the line, oh boy, and find both pieces of information. So we're going to look at, again, just exactly the same as last time, the y-intercept and the slope. Those are the two things that we need. So, like Ms. Thibodeau was saying, it doesn't matter which order you do this in, and so because of that reason, I'm going to do it in the opposite order, just to show you that it doesn't matter. All right, so you're looking for 2 points that are ideally at nice locations on the graph where they're regular points, not just kind of in the middle of the graph like over here, because that's not really that helpful. Okay, so once you have that, then we're going to look for our rise over run, just the same as last time. And in this case, we can see that we rose 3 and we ran 2. Okay, so that gives us a slope of 3/2. Then we're going to find our y-intercept, and we have helpfully, intentionally already highlighted that. We can find it right here. Okay, so then we can see that y is equal to -2 in this case, so then b will be equal to -2. Then we can put this all together to get our final equation of the line. So m, its value is 3/2, and then we have x, and then plus the y-intercept of -2. Now, remember that this is not in its most simplified form, so I'm going to make that better by saying that y is equal to 3/2x minus 2, and that would be our most simplified final best answer. Okay, it's all done. If you have questions, let us know on